In this short video, we will discuss how a computer is programmed in low-level languages, that is, binary or machine language and assembly language. Let us revise the computer definition discussed in the first video of this course. A computer is a programmable electronic device that can store, retrieve, and process data. Word programmable is a mystery word here. Why a computer is a programmable device? Computer is programmable because instructions and data are stored in the same place. Changing the instruction, we can change the operations on data. Instructions that we give to the computer, or in other words, programming, are related to storing data into memory, retrieving data from memory, and process data within the CPU. Processing covers a lot of operations like arithmetic and logical operations, and it occurs within the CPU. A computer understands zeros and ones because most of its circuits are made of transistors. Transistors can make the voltage low or high, which may be represented as 0 and 1. These transistors are wired to design gates. Gates perform logical functions when given certain type of inputs. This functionality of gates allowed designers to write instructions in form of 0 and 1. CPU designers list a specific set of instructions and assign each instruction a binary code. Fundamentally, programming a computer at hardware level is writing instructions in binary form to perform a specific function. Machine language is the language made of binary coded instructions that is used directly by the computer. List of instructions in binary are integrated in every CPU. These instructions made up of 0 and 1 can be used to program CPU. Instructions can be 4, 8, 16 or 32 bits in size depending on the word length of the computer. Programming with a limited set of instructions require that a problem be broken down into smaller steps. Assembly language was developed because memorizing instructions as strings of ones and zeros is difficult. So mnemonics were assigned to strings of zeros and ones of binary instructions to make writing a program easier. A language which uses mnemonics representing machine language instructions to write a program is called assembly language. Since computer understands only language of ones and zeros, a mechanism is needed to translate mnemonics to ones and zeros for ones and zeros. For this purpose, a program called assembler is designed. Assembler is a program that translates assembly language program into machine language program. This is how instructions are created for a computer when it is manufactured. Operational codes in ones and zeros are assigned a specific meaning. For example, all zeros means stop execution or terminate the program. 1100 means load data into the memory. Note, this is not the complete program. This is just the sample of few instructions in binary language. And this is how words are abbreviated to give memorable names to strings of ones and zeros. Instruction for terminating a program is simply the word stop here. LDWA means load a word in accumulator register. Before the instruction is the data and addressing mode for the instruction. Here 0x represents operand, 008B is operand itself in hexadecimal, and I means immediate addressing mode, which shows that word is loaded into accumulator directly. Same type of instruction is written again in third row, but it has D instead of I. D is for direct addressing, which means load word from the address 008B in the memory. Thanks for watching this video. Subscribe to support this channel and watch our latest videos.